Welcome. Thank you all for joining this webinar about the MSPM0 microcontrollers from Texas Instruments. My name is Clemens Valens. I work for Elektor, and I will be assisting our guest presenters Shreya Mandel and Luke Ledbetter, both from Texas Instruments. Shreya is a product marketing engineer for the industrial MSP microcontroller portfolio in the Americas and EMEA, which means Europe, Middle East, and Africa. Hello, Shreya. How are things in Dallas today? Maybe you are on mute.
Hi, Clemens. Can you hear me?
Yes, we can hear you.
Perfect. I'm doing well. I'm very excited for everyone to join this webinar, and we can dive into our new portfolio and answer any questions to help you get accelerated to time to market in your designs.
Okay, very good. Luke is your colleague, is an application engineer specializing in MSP microcontroller products. So hello, Luke. How are you doing?
Hi, doing good. Happy to, talk to everyone here today and then show our new microcontrollers.
Okay, excellent. So yes, today we will present the MSPM0 ARM Cortex M0 based microcontrollers from TI in quite some detail. From a device lineup and peripheral overview to setting up development tools. So there will be a lot of information, but don't worry if you can't follow along with the presentation because this webinar is being recorded and it will be available afterwards on the Elektor TV channel for replay. So you can watch it as many times as you want. At the end of this webinar, you can ask questions. The presentation, of course, not the webinar. You do this by typing them into the Q&A chat box, which is in the right bottom corner of your screen. The presentation is video recording, so we'll play that now, and after the video recording, we will do the Q&A. I think that's all I have to say for now, so I will start the video. And switch also off,
Hi everyone,
your video.
And thank you for joining our webinar. Today we'll be talking about how to rapidly develop with low-cost MSPM0 MCUs. We'll be covering the latest portfolio for our microcontrollers, as well as its feature sets, and how to get started with our ease-of-use ecosystem using different tools such as SysConfig, Analog Configurator, and Code Composer Studio. This presentation is pre-recorded. However, we'll be answering questions as they come in through the Q&A box, and we'll also be conducting a live Q&A at the end of this presentation. You can also view additional resources related to today's webinar, such as product folders, launchpads, and these slides. We hope you enjoy this presentation. Hi everyone, my name is Shreya Mandel, and I'm a product marketing engineer for our MSP microcontrollers here at Texas Instruments. Today, we'll be diving into the new ARM Cortex M0 Plus MCUs portfolio and learn how TI's code generation tools and examples will save you time and money, which we all like to hear. In developing this portfolio, we focused on 3 pillars to design our devices to be cost optimized, scalable, and simple to use. Let's dive into our cost optimization pillar. Our new portfolio of devices are available in some of the industry's smallest packages, and as I'm sure you're aware, smaller packages means a smaller system design and ultimately less cost. Small packages also enable smaller overall system designs to save your overall BOM costs. To lower costs even further, our devices are also available with a variety of integrated analog devices that can help you eliminate external components and additional costs. Let's talk about scalability. Our MSPM0 portfolio includes devices available in a variety of speeds, memory sizes, pin counts, and integrated analog options starting at 8 kilobytes to 128 kilobytes of memory, 16 to 64 pin packages, and pin-to-pin compatibility within the MSPM0 portfolio, as well as other devices in the market. And lastly, let's talk about the simple-to-use ecosystem. Our team has worked hard to make implementing MSPM0 into your product as easy as possible. With everything from graphical tools to code examples and reference designs, you're able to quickly incorporate MSPM0 into your product and ultimately accelerate your time to market. Today, we'll also be showing demos such as our tools as SysConfig and Analog Configurator. As you can see, our ARM Cortex-M0 Plus MSPM0 portfolio has a broad scalability ranging from speeds of 32 MHz and 80 MHz with flash memory from 8 KB to 128 KB in a variety of small footprint packages from SOT 16 pins to LQFP 64 pin packages. So you really can choose exactly what you need for your application. MSPM0 is categorized in two different families. So first, let's start with MSPM0L. In this family, we define it as having the lowest power at 0.1 microamps in shutdown mode. The devices in this family will operate at a speed of 32 MHz and go up to 64 KB in flash and is available in packages up to 32 pins. We have 46 different variants to order from today, starting at 39 cents at 1 KU volumes. MSPM0L devices offers a 12-bit 1.5 megasamples per second ADC with configurable internal voltage reference, one dual mode, fast mode, and ultra low power mode comparator with a built-in reference stack. Two zero drift, zero crossover operational amplifiers with programmable gain, and one general purpose amplifier and an on-chip temperature sensor. As you can see, MSPM0L definitely has a lot of benefits that you can put in your applications. Moving on to our second family, MSPM0G series. MSPM0G is defined as having a higher compute speed operating at 80 MHz, making them our fastest compute devices in this MSPM0 portfolio. This family goes up to 128 KB flash memory and offers high-performance analog peripherals, such as two 12-bit 4 megasamples per second ADCs, a configurable internal shared voltage reference, one 12-bit 1 megasample per second DAC, three dual-mode, fast mode, and ultra-low power mode comparators with built-in reference DACs, and two zero drift, zero crossover, and rail-to-rail op-amps with programmable gain up to 32 times, and one general-purpose rail-to-rail amplifier. These devices also have other advanced peripherals, such as Math Accelerator to enable fast and efficient math operations, reduce calculation time of division, square root, and trigonometric calculations. And MSPM0G also has CAN-FD for automotive use cases. Both MSPM0L and MSPM0G devices provide a variety of analog features to support different system designs. Now that you're familiar with our new portfolio, I'm passing it over to our applications engineer, Evan, who will show you how easy it is to prototype with these devices.
Thanks, Shreya. Next, I'm going to talk about the MSPM0 SDK and ecosystem. We've been working hard to ensure our devices are easy to use and simple to set up so you can get started without spending hours reading documentation. I'm going to focus on a couple key areas: the MSPM0 Software Development Kit, the MSPM0 Launchpad ecosystem, our code generation tools SysConfig and Analog Configurator, and our new CCS Thea IDE. Let's begin on the software side. You can think of the MSPM0 SDK, or Software Development Kit, as the software starting point for your designs. Inside the MSPM0 SDK, there are many references that you can leverage to get prototyping quickly. DriverLib is our low-level API that wraps the device registers in a high-performance, well-documented format so that you can start writing code without having to spend time digging through the reference manual. Our software team has spent a lot of time optimizing DriverLib to minimize the memory footprint and performance overhead. When compared to equivalent competitor low-level libraries, TI's MSPM0 DriverLib weighs in at half the size for a typical application. The MSPM0 SDK contains over 200 code examples that demonstrate each device peripheral in different modes of operation. You can use these examples as a reference or as a starting point for your application. In addition to simple peripheral examples, the MSPM0 SDK also offers support for RTOS and libraries such as SMBus, IQmath, PMBus, Motor Control, Automotive, and Diagnostic Libraries as well. You can visit dev.ti or click the link in the Resources tab to start exploring the code and documentation. Now I want to talk about our hardware development tools. The Launchpad is the fastest way for you to evaluate the MSPM0 family of microcontrollers. Every Launchpad comes with an integrated USB debugger, so all you have to do is plug it into your PC and load an example. You can even load an example and debug code from the web using CCS Cloud. More on that later. Every MSP device will have a corresponding Launchpad that exposes the full pinout and feature set of the device. This enables designers to build prototypes that are representative of their system without the need to manufacture a printed circuit board. The goal here is to provide the right hardware tools for designers like you to build confidence in the MSPM0 as fast as possible. Another great feature of the Launchpad ecosystem is the booster packs. You can plug them directly into the Launchpad headers. Booster packs provide an easy way to add additional functionality to your prototype without having to do any prototype work yourself. No breadboarding, no custom PCBs. This is a great way to evaluate how the MSPM0 will work with other devices. If you want to start prototyping with MSPM0 today, order a Launchpad on ti.com. It's the best way to get started. Next, I want to talk about two tools that I'm really excited about: SysConfig and Analog Configurator. We're investing heavily into our code generation and graphical configuration tools because we know it's much more fun to build prototypes than it is to spend hours reading documentation. We want our engineers to start prototyping with our devices as fast as possible. But more importantly, we know that prototyping is the only way to build confidence in new designs and find issues that need to be corrected at the system level. This is where tools like SysConfig and Analog Configurator can really help bridge the gap and take you from idea to functioning prototype really quickly. Let's begin with SysConfig. SysConfig is a graphical configuration tool that presents a view of every peripheral inside MSPM0. I think the best way to get a sense of what SysConfig can do is to build a simple project. So let's build a project that will sample an analog signal and generate a PWM output with a duty cycle that corresponds to an analog input voltage. To start, I'm going to go to dev.ti.com. I'm going to go to the Resource Explorer and find the MSPM0 SDK. To do that, I can select ARM-based microcontrollers, embedded software, MSPM0 SDK, examples, development tools, MSPM0L Launchpad. I'm going to drill down to the driver lib, and I'm going to pick an example that matches the functionality I'm trying to achieve. Remember, I'm trying to convert an ADC input into a PWM output. I happen to know that ADC monitor supply is a good starting point. We're just going to adapt it to not monitor the supply, but instead monitor an external pin. I'm going to click ADC monitor supply, no RTOS. I'll choose the TI compiler. And I'm going to click the import button to import this directly into CCS. Once I'm in CCS, I'm going to navigate to the project and see the files. There are two important files here: ADC12 monitor supply.c and ADC12 monitor supply.sysconfig. Sysconfig contains all the device configuration, while the C file has all the application code. Let's open the sysconfig file. Inside the sysconfig file, we see a view of all the peripherals inside the device. Right now, let's modify the ADC to, instead of sample the internal monitor, supply monitor, to sample an external pin. I'm going to drill down and select channel 0. You can see now that sysconfig lets me know that I'm sampling on PA27. Now that we have the first half of this project complete, it's time to create the timer PWM configuration. I'm going to add a timer PWM instance by clicking the plus button next to timer PWM. Inside the PWM configuration, I'm greeted with all the settings and configuration options that I have control over. I'm going to change the PWM period count to 4095 to match the 12-bit nature of the input sample. I'm also going to check Start Timer so that the timer starts by default when the application starts. I'm going to deselect PWM channel 1 because I only need one output, and I'm going to set a default duty cycle of 50%. Finally, I'm going to select which pin I want to use. SysConfig will automatically pick a timer instance that is routed to the pin I choose. So for example, I'm going to pick PA26 because this is routed to an LED on the Launchpad. SysConfig automatically matches timer G1 to this pin. One thing that's nice about SysConfig is you can see all the code it's generated. Already, just with a couple clicks, we've generated over 150 lines of configuration code. That would have been code we would have to write ourselves if it weren't for SysConfig. The nice thing about SysConfig is if I do decide to change a setting, it'll show me exactly what code was changed as a result. This is a nice way to really understand what SysConfig is doing under the hood. I'm going to check that back, and now I'm going to go back to the application code. I will, however, snag a piece of code here that I'm going to end up using. Back in CCS, I'm going to open the ADC12 monitor supply.c file. Since this code contains code that I don't need, I'm going to trim what I don't need. Now, every time the ADC samples and enters the main loop, I'm going to update the timer. Instead of setting the default value, I'll use the ADC result. Now this code is ready to go. When I'm ready to deploy it, I'll right-click and hit Debug Project. As you can see, as I twist the knob on my power supply, the LED brightness changes, showing that we are indeed translating an analog voltage into a PWM output. Next, I want to talk about Analog Configurator, the other graphical configuration tool that helps speed up prototyping with MSPM0. Analog Configurator is a schematic style configuration tool. MSPM0 devices offer really flexible analog components including dual ADCs, op-amps, comparators, and DACs. The high level of integration and interconnectivity makes it possible to create complex signal conditioning circuits completely inside the MSPM0. However, this flexibility can make it difficult to envision, let alone configure, an analog signal chain using MSPM0. This is where Analog Configurator can be a big help. Analog Configurator allows the designer to see all the available analog peripherals inside the device and create schematic style connections between them. The best way to understand Analog Configurator is to see it in action. Let's do a quick example. As you can see, all the analog peripherals available are in the left sidebar. You can drag them out and create schematic style connections between them to develop custom analog signal chains. When you're ready to deploy them, you can hit Reconfigure Target Device, and this configuration will be flashed to a launchpad or whatever you have connected. If you want to see the signal acquisition performance, you can enable plotting to view a real-time waveform of what the signal is capturing and sending to the ADC. So now I want to switch gears and talk about what I'm calling MSPM0 subsystems. The goal here is to create content to solve common MCU design challenges. That means develop examples where we connect peripherals in ways that are common in MCU configurations. For example, an MSPM0 subsystem could be converting ADC and sending it out to SPI, or doing FIR low-pass filtering, or being a power sequencer, or one-wire emulation. There are many more such examples that you could think of where you can connect peripherals in common use cases to create what we're calling a subsystem. An MSPM0 subsystem is a specific functionality that MSPM0 can provide. An MSPM0 subsystem is not a full reference design. You can think of subsystems as building blocks that you can connect to build a full design. Let's go into some examples so you can get an idea of what a subsystem is. In this subsystem, we're converting ADC and sending it to a digital communications peripheral, such as SPI, I2C, or UART. MSPM0 is a great fit for this application because even on our lowest end device, the MSPM0L, which is available today, we have a 1.5 megasample 12-bit ADC starting at 39 cents for 1 KU. This is a great offering, and so you can use this as an ADC inside your design. If you need to reduce the size of your solution on your PCB, MSPM0 has lots of flexible packaging options. The MSPM0 also can pre-process the data in ways that you can use to prevent artifacts from appearing in your signals before sending it out through the UART, the SPI, or the I2C. MSPM0 is a really great fit for any type of analog application where you need to translate that over to a digital interface. The next subsystem I want to talk about is a power sequencer and a voltage supervisor. A power sequencer releases specific enables in a specific sequence to make sure that the voltage supplies are all sequenced correctly, not to damage the system. In addition, the ADCs on the MSPM0G are even more powerful than the ones on the MSPM0L. MSPM0G features dual 4 megasample per second ADCs at 12 bits. It offers up to 16 external channels. In addition, you can use op-amps to do buffering for signals going into the ADCs. Also, there's up to 3 comparators available on MSPM0G. You can use these analog capabilities to build a power sequencer and a voltage supervisor. Some advantages of using MSPM0 are the fast cold boot time at 200 microseconds to get the system started quickly. The precise cycle-by-cycle control of GPIO is enabled by a distinct bus inside the CPU that goes directly to the GPIO, so you can get really granular control of the GPIO outputs. The next subsystem I want to talk about is a digital FIR filter using high-performance MSPM0G. In this subsystem, we sample an analog signal with the ADC, we apply an FIR filtering algorithm to do signal processing, specifically to remove noise, and then we send that filtered output through the DAC, or we can use it internally. The advantages of MSPM0 is we have an internal math accelerator to improve the performance of the digital FIR algorithm. This type of subsystem improves the SNR without any additional components. Additionally, since it's based on software, we can adjust filter parameters such as cutoff frequency and filter order on the fly. I also want to mention one-wire target emulation as a really interesting subsystem for MSPM0. One-wire is a protocol that's often used in appliances where things need to be connected on the fly, also called hot swappable. The advantage is one-wire uses very few pins to communicate bidirectionally and consume power. This all happens over one pin and a ground. MSPM0 is a great fit for emulating this type of interface. The open drain pins enable communication at up to 5 volts. Also, the low power of MSPM0 makes it so that it can be parasitically powered by the one-wire bus. The software flexibility combined with the I/O flexibility makes it possible to emulate one wire without too much overhead. Since it's based on software, you can plug in different components all within the same microcontroller. For example, you can add an EEPROM emulation package to create an EEPROM one-wire device. In review, MSP is a cost-optimized, scalable, simple-to-use family of microcontrollers. Our investments in the MSPM0 SDK, Launchpad, graphical configuration, and new CCS THEA editor improve the experience and make these devices really easy to use. I'd like to open it up now for questions.
So that's it for the presentation. We will now switch to Q&A mode. So if you have any questions, please type them in the Q&A box on the right-hand bottom corner of your screen. I have one question, which is also in the Q&A box. The relation of the MSP M0 to the old MSP or the MSP 430 series. Is there a relation? And if so, can you explain it?
Yeah, I can take that question. Can you hear me?
Yes.
Okay, perfect. Yeah, so great question. So our existing MSP 430 portfolio, we do have a migration guide from MSP 430 to MSP M0 available on the web today, so we can send that in the chat if you want to take a look. But yeah, so in terms of if you're thinking like pin-to-pin compatibility, that's not the case. But in terms of how we can migrate over from our 430 MCUs to M0, we have that ability. And once again, within the portfolio in MSPM0, all of those MCUs are pin-to-pin compatible within the same package there.
Okay, so in peripherals, are they compatible between the M0 and the 430 or not at all?
Well, I mean, the MSPM0 portfolio has different, I mean, they're similar peripherals, but the performance is going to be different, right? The different types of like what we have in like our ADC or op amps are going to be different from 430. 430 also has its kind of aspects such as niche aspects like capacitive touch, ultrasonic sensing, integrated LCD, integrated USB. So there's still a lot of, I guess, peripherals that MSP 430 has. We're working on to continue kind of a roadmap for MSPM0, but there are like similar devices that you can, maybe there's a project that you're using an older 430 device that you want to migrate over to MSPM0. So you're going to have higher, like better performance, higher features in MSPM0 if you're looking from an old MSP 430 device.
Okay, some of these slides said it was mentioned coming soon. Does it mean are these old slides? The devices are available now?
Yeah, no, the devices are available. Like for the MSPM0 portfolio, we have our MSPM0L devices that are 32 megahertz up to 64 kilobytes. That's all available today. Our MSPM0G devices are also, you can see the different product folders that are available on the web as well today. And throughout this month actually, and towards we'll be adding more different variants of like different package variants to kind of build our portfolio. But today you can order samples, launch pads, or EVMs on ti.com/MSPM0.
Okay, everything we saw in the presentation is available to you.
Okay. And I just submitted a just the migration guide from MSP 430 to MSPM0 into the chat, so you guys can take a look.
Very good. Okay, next question. So what is the usable ENOP of the 12-bit ADC, where ENOP means the effective number of bits for those who don't know? Do you have an answer to that one?
I can answer this one. So the ENOP performance, it does depend on kind of the situation that you have. So innately with an external reference, it has 11.1 bits of ENOP. But we do also have hardware averaging for the ADC. So you can, without having to have a software implementation, you can hardware average, I believe, up to 128. So with the hardware averaging, you can improve your ENOP results. You can also do some neat tricks with like the op amp as well with the ADC assisted chopping. So you can improve your ENOP performance as well, aside from that 11.1, the external reference.
Okay, thank you. The next question is the old TI RTOS not supported nor recommended?
So there are, right now we have the free RTOS for our support that we're currently doing. TI drivers, we have some that are out there. We're also going to have Zephyr support. So right now, those are the kind of RTOS options that we provide. We're expanding, I think, on TI RTOS in the future, but currently it's not fully supported.
Okay. And then we have a question about space grade. Do you have any red hardened versions?
No, great question. So right now for our MSPM0 portfolio, we do not have any radiation hardened versions for these devices, but this is something that we are looking at for the future. I mean, right now we do have the like our temperature range right now is -40 to 125 degrees Celsius. But we do have existing space grade devices that have been tested in the MSP 430 space portfolio. So if that's something you're looking into, we do have some devices there.
Okay, I was not planning on building a satellite right now, but maybe someone is. Yeah, you showed some nice tools, software tools. Are they for free, or is there a license to pay or anything?
Yeah, no, this is a great question. No, this is free. When you go on our product folders, you can just download our software tools, and you can download it into the cloud or download it independently. And yeah, it comes with tons of resources, as mentioned in the webinar, but different types of code examples. We have MSP academies where you want to look based off peripherals, truly understand how we can use it within the MCU. Yeah, so the software side, you can just download it and get started immediately.
Okay. Then about this, will TI relaunch the watch-based evaluation system? I remember that one. I had one.
Yeah, no, so we basically, this is great feedback for us, but currently this is kind of outside of the scope for our MSP portfolio due to the wireless connectivity aspect, but this is something that we might look into the future.
Yes, wireless, I saw a question about it later. First, are there any connectors like Arduino or Grove or Quick or Stemma available on the evaluation boards?
Yeah, for connectors, we do have, there's a USB that's on there that you can connect to. And it also has different communication protocols as well. So if you wanted like UART, I2C, but there aren't connected pins for that, but they're available pinned out with header pins. There's also the ARM connector pin for programming that you could use an external programmer. I think there were questions about that later, so we'll also get into that on those other questions. So standard connectors, I'd mostly just say the USB that's on there you can use to program. The MSPM0 devices do not have USB innately, but there's connections through the EasyFET, the external XTS 110 that we have on there. And so through that, you can connect to the launchpad.
Okay, but there are no, you cannot plug Arduino shields on the board to
only through like the pinouts that are on the header pins. So if you look at the board, there's pins, but there's not a Arduino or I guess Grove, Wick, Stemma connectors.
Okay. Then back to the compiler. Does it have code optimization levels?
Yes. So our compiler, we can also have GCC as the kind of third-party compiler. So we have GCC support, and TI Clang is our version of the compilers. So for TI Clang, we have different optimization levels. If you go to the CCS and you right-click the project, you can actually change the optimization levels. So for debugging specifically, it's sometimes helpful to just completely remove the optimization, right? So you can do that. You can also increase optimization levels. Default in our examples, we have it set to 2. If you hover over it, you can see what that really means on like what the difference is between each optimization level is. So yes, we support optimization levels.
As you mentioned it already, debugging. No,
Yeah.
Echo. Yes, please
Yeah,
continue.
so we have a debugger and a production programmer available. So when you go look at our product folder and you scroll down to design and development, we have the XDS 110 JTAG debug probe, as well as the MSP Gang production programmer. So you are able to program up to like 8 identical devices at the same time there. So we have the tools necessary to help you kind of start evaluating your projects.
Okay.
For the third-party debugger, currently we're supporting the J-Link Seger. So if you already have that from some other device, you can also use that on our ARM devices here. And the launchpads also come with an XTS 110 on board. So if you download or I guess buy one of those, you can use the launchpads debugger as well.
And they allow you to do set breakpoints and things like that. Inspect variables. Yep. Okay. Then, is there a non-cloud-based flavor of the SDK?
Yeah, you can download the SDK. If you go to any of the product folders and then go to software, the software section of those, I guess the device product overview, you can see, you can download the SDK onto your own desktop, so you don't need to be connected to the cloud all the time. You do the same thing with CCS. You can download it. The cloud is there for if you don't want to download something, or if you want to do like a quick evaluation, you can go on our developer zone and you can select the example. You can test it out on the cloud. And then if you want to bring it back onto your actual desktop, you can also download it and import it that way.
Yeah, so we wanted to provide like the flexibility of both, hey, you want to evaluate in your browser or independently on your desktop.
Okay, great. So how much does this all cost?
Yeah, so go ahead, Luke. If you
well, the compiler is free, so that's a nice thing.
you say the
hardware debugger, you can buy a XDS 110 externally. I think it's 178. You can double check me, Shreya.
135 for
135.
and then the Launchpad itself is $16.99 from TI.com. But if you are in contact with maybe your technical sales representatives or field application engineers from TI, maybe we'll be able to, we have like options to do like samples.ti.com and things like that. But that's just kind of what we have our offerings on the web today.
You said $16.99. Is it 16 or 60?
16. No, 16. Yeah.
Almost $17 USD.
Yeah, it's easier to remember. So you already mentioned it briefly. Is there a version with wireless multi-protocol built in?
Not right now. No, we don't have any offerings available at the moment, but this is something that we are looking into in the future. We're very close with the connectivity business unit. So we also have some new devices coming out as well. So we'll kind of integrate something, but right now we don't have anything to offer.
Okay. And what about the CAN bus?
Yeah, so the MSPM0G device does have CAN bus. It needs a CAN transceiver, so we have TCAN transceivers available on TI.com, and so you can pair with one of those. We have an academy actually that goes over the CAN protocol and how to use our CAN protocol with the CAN transceiver to get communication. Typically, the CAN bus is used in automotive, or I've even seen it in medical actually. So just if you need a more robust communication protocol.
And then this one is very fashionable. Does the MSPM0 have state machine blocks? Silence. These blocks have popped up in recent microcontrollers from competitors. So do you have them too?
Mm-hmm. Yeah, we currently don't have state machine blocks as a drag and drop, I guess, for GUI configuration. We do have an analog configurator that you can configure the analog portions for, but for a state machine, you'd have to code it currently.
I think here is meant the peripheral which can execute a state machine. It's not a software state machine. So it's a programmable peripheral.
I'd say no.
Mm.
I can mention a well-known competitor in our audience, but I won't. Who become very popular thanks to this feature. So what is the cheapest route to try the new range of devices?
Yeah, no, that's a great question. As mentioned before, right, we want to make this as cost optimized and simple to use for all of our customers to use. So I would say is going on TI.com and you can order some samples. That would be your cheapest way to start off with these devices for both M0L, M0G. If you want to, I would also recommend is if you want to just order the superset device too, so you can have all of the peripherals, both for MSPM0L 1306 and MSPM0G 3507. So you can take a look at, because you can always not use those higher peripherals that are in the superset devices. So that would be something that you can integrate. And as mentioned, also getting a Launchpad to get started and kind of go through, and we already said our SDK and software side is all free. So really it's just going to our ti.com/MSPM0, finding the product that you're interested in and ordering samples and getting them shipped to you quickly.
Okay, you probably mentioned this, but how do you program it with an executable? Is there a bootloader built in, a serial port bootloader, or over USB or something? No, you said there is no USB port built in, huh?
Yeah, there's BSL on the device. So innately, you have kind of two programming options. You have the ARM SWT programmers, so with SW clock, and then SWDIO. That's an ARM standard. So that's our kind of recommended method to wire there. For BSL, for the Bootstrap loader, we have UART and I2C, and we also have secondary BSL. So we have some examples. We have a whole document on the secondary BSL. So you can customize your own BSL if you want to change kind of the flow of the Bootstrap loading. You can also change which peripherals you're being used as long as you kind of execute it. And then we have a ROM BSL as well. So that's innate in the device.
Okay. So then I2S, you made a typo. Is there support for I2S on the MSP M0 family?
There's no I2S currently on the device.
Okay, that's a short answer. Laura one, well, we already answered that one, so we can skip it. Do you plan to share the recording of this webinar? Well, yes, of course. I already said it in the beginning. This webinar is being recorded and will be available on our YouTube channel afterwards. And I suppose that the presentation is already available on the TI website. I think Shreya can answer that.
Yeah, this presentation is just uploaded into the webinar itself. You can find all of the information on our website, like ti.com/MSPM0. But if you need the slides, we provided the slides to this webinar, so you can take a look at that.
So how does booting via UART and I2C work?
Yeah, so again, the document will probably do a way better job than my explanation here because it's a full-fledged documentation. But there are commands for it. So on the innate ROM bootloader, we'll have the command kind of protocol set out, so you can send the commands via UART I2C. But there is also the, possibility for a secondary bootloader. And so by doing that, I think there's 4 functions that you need to program so that it kind of knows what to talk to. But after that, you can put anything inside those functions, so you can do your own custom bootloader that way. The internal flash can be programmed, this way. There's also a flash plugin in that document. I think Shreya just linked it into here if you want kind of a full-fledged explanation. But that's kind of the shorthand, I would say.
Okay, thank you. So are you planning to integrate FRAM memory?
There's no plans as of now to integrate FRAM that we have in MSP430 into MSPM0. So that's why, as I've mentioned, for our MSP430 portfolio, we still have a great amount of devices that you guys can take a look at and utilize for the different applications. But for now, we're kind of keeping Flash for MSPM0 and then FRAM and Flash for 430 portfolio.
Here we have a specific question about migrating. Is there a migration process for the MSP430 F67XX to the new family?
Yeah, so the F67XX, they have actually, because this is an older MSP430 device, but this is kind of in the metering space, some higher like 24-bit Sigma Delta ADCs. So right now we don't have anything at the moment, but stay tuned on what could happen.
Okay. So what about low power modes?
Yeah. As mentioned, and Luke can add a little bit more, what we really wanted to do, everyone loved and still do love the fact that MSP430 is known as that ultra low power microcontroller. So taking that same aspect and putting it into our MSPM0 portfolio was very important to us. And specifically in our family, MSPM0L, you can say L for low power, is what we have we still have our optimized low power modes. You know, we have the run at 71 microamps per megahertz, stop, standby, shutdown. So we do support these low power modes, not only in M0L, but that I will say has like the best optimized low power modes. But we also have an M0G as well. And Luke, you can add some more detail.
Yeah. The low power modes, we also have I guess, specific GPIO pins and different peripherals that can actually, they'll be off during a super low power mode, but there's an asynchronous clock request that can come in. And so you can actually get an interrupt and wake up from that low power mode. So you can be in a lower power state. The peripheral, even though it needs a higher power mode, it'll wake up, do its thing, and then go back to sleep. So it helps still keep a low power cost, even though you're not in that low power mode for that specific peripheral. But again, we have like standby mode as well that you can have the RTC enabled still.
So it was 71 microamps per megahertz, you said?
71 microamps per megahertz, yeah, for the run mode.
Microamps, yeah, I don't know what I said. Okay.
Yeah, so 32 megahertz.
This is related to the previous question. Pure ARM 32-bit or close to 16-bit? Well, I suppose it's 32-bit.
Mm-hmm.
Yes.
Yep, 32 bits. I believe the 430s were 16-bit. So
correct.
Yeah, it's used the ARM0 M0 plus core. So.
Mm-hmm.
So what about security?
Yeah, we have many security peripherals, especially on the G device. We have a AES, which is kind of the encryption system. So you can have some encryption on there. You have the TRNG, so we have a true random number generator on the device. There's also CRC. CRC is available on all the devices. And then I think that's it for the G and L, right, Shreya?
Yeah, those are the main ones.
Okay. A question about power supplies. How many supply inputs are there?
For these devices, for the power supply input, it's just VCC for these devices, and then you need your vCore capacitor, but there's no secondary power input.
Here we have another. Oh, keep jumping up. Does MSPM0 support DSP instructions?
Yeah, so we do have some digital signal processing. We actually have an example on the SeamSys, the ARM digital signal processing. I believe it's in that developer zone under the SDK. And so we have fast Fourier transforms as our example. So you can see some, I guess, DSP processing on that. We also have a math accelerator. It doesn't help with an FFT, but for other digital signal processing, it's very helpful.
Okay,
yeah, and the math accelerator is available in our MSPM0G family. So optimizing like the times for operations for any like trigonometric functions and basic math type functions. So that's helpful for any application.
Okay, then compared to the ARM Tiva controller, why would you recommend the MSP430?
I guess I would pose the question is why we recommend M0. I mean, it really just depends on, again, I mean, ARM Tiva is also like this, the TM4C family. Depending on what type of core that you want to be using, M4 is what the TM4C ARM Tiva microcontrollers are using. We have the M0 Plus core. It's not, I wouldn't necessarily say, which one you should use versus the other, but for our devices with our portfolio specifically, I would say very like, especially in the M0L family, we can use it a lot in like different housekeeping functions, supervisory functions. We have, I would say, probably a more scalable portfolio, and we are continuing to invest in it as well. So we're very excited to share. This is just the beginning, but in terms of more investment in particular for MSPM0 portfolio, I think kind of choosing our platform can help you like in the long term, I would say.
Okay. One last question. Sorry. Can I plug in Boost XL Touch LCD display with MSPM0? I do not know what that is.
Yeah. So the Boost XL Touch LCD display is one of our booster pack kind of add-ons that you have. So with our EVMs and the launch pads, the MSPM0L and MSPM0G have their own launch pad. but you can use all the booster pack, I guess, little add-ons like this one, this Boost XL Touch. There's other ones on there. There's an audio one that we use, even in our academies, we use them. I think there's another LCD display that I've used personally that is also conforms to the booster pack standard. So as long as they fit the booster packs, you can plug it on the board. You can test out like the SPI communication, I2C to connect to those peripherals, and then have your output there.
Okay. There's this last question, but it's not really a question, but it summarizes it nicely. Very nice and interesting presentation. Thanks a lot. And bye. Well, it's not bye immediately. Let me go back to the slide first. Where did it go? Here it is. So I think you're nearing the end of the webinar anyway. We had a lot of questions, which is really good. I think it was a nice presentation. Thank you very much, Shreya and Luke. I hope it was interesting for you all spectators. As I said at the beginning, this webinar will be available in a few days on the Elektor TV channel, and then you can watch it again and again and again. We hope to see you again for the next Elektor webinar, which is on October the 11th, if I'm not mistaken, and that will be about plug-and-play industrial communications modules. Having that said, I would like to thank you, Shreya and Luke, for doing this webinar with me, and thank you all for attending. Goodbye.